Industrial Metaverse, hype or hope? Welcome to our exploration into the Industrial Metaverse. You've heard it, you've read it, you've seen it. The Metaverse is dead. Or so some believe. In May 2023, Business Insider published an article by Ed Zitron proclaiming the Metaverse's demise, replaced by rising technologies like AI and self-driving cars. And it is true, there was a lot of hype. Not long after Facebook announced the Metaverse in 2021, consulting companies and investors rushed to estimate its potential. Yet, by 2023, this hype was fading, with key players shifting focus or shutting down projects, and many self-proclaimed Metaverse experts turning their attention to greener pastures. So, was the Metaverse dead on arrival, or did a lack of coherent vision hasten its fall? What if we're not seeing the full potential of the Metaverse because all the hype is in the way? Let's think about when the internet first started. We didn't know how it would grow or change our lives. The Metaverse could be the same, with a potential we're still trying to understand. There are strong indicators that the industry could be where the Metaverse has the most impact. The Industrial Metaverse isn't about creating fantasy worlds. It's about connecting the real world with the digital to solve real-world problems. Industry worldwide is embracing Metaverse technologies. It's about real-world impact. It's about improving the way we do things in the real world. It's about delivering tangible benefits for consumers, business, and society. And the Industrial Metaverse is very much alive. Research from the World Economic Forum supports this. Quote, "The Metaverse will have its biggest immediate impact not in the consumer sector, but on industry and business. Digital twin technology is already in widespread use across industry in fields including shipping and aerospace. Many technologies developed for the Industrial Metaverse will make their way into the consumer metaverse. Adoption could begin in industry and later spread to consumers, a reversal of what people expected when the hype started 2 years back. A key building block of the Industrial Metaverse is the digital twin. A digital but physics-based copy of real-world machines, factories, or buildings. Significant strides have been made in their development. Digital twins are used in the automotive, aerospace, and manufacturing sectors, just to name a few. One domain where digital twins are making a profound impact is healthcare. For example, there are 57 million people worldwide living with limb loss or limb difference, and for many, prosthetic limbs have been out of reach. Unlimited Tomorrow tackled this issue with True Limb, a lightweight, affordable, and realistic prosthetic limb. But there was a challenge: designing the socket where the prosthetic attaches. But by using digital twin technology, they precisely simulated and adjusted the socket geometry for a perfect fit. The result? Prostheses that are not only cost-effective, but produced at unprecedented speed. Another sector reaping the benefits of digital twins is manufacturing. Imagine having a full-scale digital replica of an entire factory. That's exactly what we have with Siemens' first native digital twin factory in Nanjing, China. The factory was first designed virtually, enabling testing and validation before physical construction. This led to an increase in productivity by up to 20%, manufacturing flexibility by 30%, and space efficiency by 40%. The power of digital twin technology is also reshaping urban planning. For instance, the digital twin of Berlin's Siemensstadt allowed us to construct infrastructure for an entire city district virtually first, identifying and rectifying potential costly errors before real-world execution. This innovative approach supports accessibility, affordability, and sustainability in urban development. We're even venturing underwater, using digital twins to conserve coral reefs. The first ever coral reef digital twin provides scientists with vital data, aiding in the preservation of this crucial ecosystem currently at risk. Finally, we join forces with Freyr, a startup with ambitions to produce batteries on a grand scale. With the digital twin of their future factories, they are making more informed engineering decisions, speeding up construction, and enhancing the production of high-performing, affordable EV batteries. As we survey the progression of technology in the past few decades, it becomes clear that the Industrial Metaverse is not a sudden revolution, but rather an evolution that traces its roots back to the earliest efforts of modeling physical entities within a digital environment. Let's take a look how it all began. Circa 1980, early adopters of computer-aided design were focused primarily on geometric representation and single physics simulation. By 1985, the concept of computer-aided design, first coined by MIT researcher Douglas T. Ross in 1959, truly began to gain traction. This period saw the rise of computer-aided system engineering and multi-physics simulations. This pioneering phase of three-dimensional modeling and computer-aided engineering marked the initial steps in a journey of digital twin technology. The dawn of the new millennium saw the extensive spread of product lifecycle management, PLM software, across the industrial sector, representing the second phase of digital twin development. This allowed the prediction and simulation of physical systems under different conditions, leveraging the digital twin. In addition to the existing capabilities, model-based engineering and collaboration became integral features. Fast forward to just 15 years later, the era of the digital twin had commenced. Key innovations of this time were software as a service and model-based operation. Our timeline now brings us to the present, as we stand at the dawn of the Industrial Metaverse, characterized by persistence, immersion, real-time operation. We have come a long way over the last decades. Digital twins are now photorealistic, and we will not only use them to simulate the real-world operation of products and systems, we will use them to activate and control physical assets in real time. Digital twins will be synchronized with their physical counterparts. The gap between virtual and real worlds will disappear. And this is where it gets exciting. With the Industrial Metaverse, we will now open the doors to new, extraordinary capabilities, enabling new and powerful ways to experience and interact with the digital twin. Here's what we can achieve. We can visualize the digital twin. Think of it as stepping into a lifelike digital room. You can see the digital twin of a machine or system right in its context, exploring it in a realistic environment, gaining insights like never before. We can bring collaboration to a whole new level. Engineers and designers can meet inside the digital room, even if they're worlds apart in reality. Together, they can review the digital twin, discuss changes, and make those adjustments on the spot. We can enable continuous interaction with the digital twin. It's not a one-time visit. Teams can continuously and interactively evaluate, simulate, and predict the behavior of the digital twin and its corresponding real assets. It's a hands-on experience that's always accessible. And we will transform how we work and manage the real world. That is what differentiates the industrial metaverse from other areas, as the real and digital world are always synchronized. Here's where it gets remarkable. In the industrial metaverse, we can not only design, but also monitor, analyze, and manage real assets, all in a close loop with their digital counterparts. It's a fusion of creation and control, leading to smarter and more efficient operations. The line between the virtual and real worlds isn't just fading, it's opening doors to innovation and collaboration like never before. The industrial metaverse transforms how we see, interact with, and utilize the digital twin. The emergence of the industrial metaverse is enabled by key technological advancements. Let's uncover the technologies that are the catalysts for this transformation. These are digital twins as the key building blocks, Internet of Things, IoT, edge and cloud computing, artificial intelligence, AI, and machine learning, ML. Virtual and augmented reality, VR, AR, advanced networks, 5G, 6G. Blockchain. Despite the clear advantages, you may ask yourself, why hasn't the industrial metaverse been universally adopted yet? The answer lies in overcoming 3 significant challenges. The primary obstacles that we need to address are connectivity. Most of us take connectivity for granted, but it's still a major challenge in many parts of the world, especially in rural areas. In the industrial space, high-speed connectivity is vital. When multiple machines and systems work together in a production line or production plant, every millisecond of latency makes a difference. To make the industrial metaverse persistent, immersive, and real-time, connectivity must be fast, reliable, and end-to-end. Interoperability, the ability of different systems to communicate and share data, is another hurdle. Legacy systems often lack standard interfaces or connectivity, so adopting open APIs, compatible data formats, and standard protocols is critical. The most pressing challenge is a lack of skills. We're facing a 16-year peak in global talent shortage, with a predicted deficit of 85 million skilled workers by 2030. 3 out of 4 organizations are struggling to find talent to meet their needs. And fewer than 3 out of 10 companies hiring for roles find the right candidates without difficulty. However, technology can also help mitigate this problem. The industrial metaverse can facilitate collaboration in an immersive, real-time environment, offering access to expert skills and virtual training modules. And AI can handle repetitive tasks, letting humans focus on their strengths. So that's where we're at. But how does Siemens help to enable the industrial metaverse? And why? Our strategy at Siemens is to combine the real and digital worlds to help customers boost productivity, improve the resource efficiency of their operations, and to make their operations, as well as our own operations, more sustainable. To us, that is what digital transformation is all about. And that is the larger purpose of the industrial metaverse. The question we asked was this: how can we best accelerate this transformation? How can we get the industrial metaverse up and running faster and on a larger scale? Our answer to that question is Siemens Accelerator, the open digital business platform. Siemens Accelerator is a digital business platform that's open, interoperable, flexible, and offers software as a service. Open means standard APIs underpin all offerings, ensuring powerful data analytics and eliminating vendor lock-in. Interoperability ensures seamless communication along domain-specific digital threads. Flexibility guarantees a modular offering approach, enabling customers to pick, scale, and customize solutions as needed. With as-a-service offerings, we reduce operational complexity, lower initial investments, and ensure easy deployment, providing customers access to the latest technology on demand with costs based on usage. The Siemens Accelerator comprises 3 components: a modular portfolio of IoT-enabled solutions, an evolving marketplace, and a growing ecosystem of certified members. Although we're one of the top 10 software companies worldwide, investing close to $5 billion in R&D every year, we believe in fostering strong partnerships to achieve our goals. We cannot do this alone. No one can. We are building strong partnerships in the Siemens Accelerator ecosystem. More than 60 companies already joined us, including Accenture, Amazon Web Services, Microsoft, NVIDIA, and SAP, plus many startups and small and medium enterprises. Finally, is the Industrial Metaverse a matter of hype or hope? Well, we can definitely do without the hype. If we lose the hype, we gain the opportunity to focus on what really matters. History teaches us that to be adopted on a large scale, technology must deliver real-world benefits. Once the benefits are established, that can happen very fast. We have every reason for hope. Never before in the history of humanity did we have so many powerful technologies to solve real-world problems and to deliver real-world benefits. Our hope is that the Industrial Metaverse will help us do that.